Here we have another problem, another example. We have a box of mass M that's sitting, resting on an inclined plane, not moving, as shown, and we'd like to know what the normal force is. That's the first question that we'd like answered. What is the normal force? Well, normal force means perpendicular, so that would be this force. The downward force to the center of the Earth is mg, and so the normal force we get with application of a little bit of trigonometry. Theta's in here, and we get mg cosine theta. That's the normal force. What is the force of friction acting on the box? Well, in order to do that, we know that the box is in equilibrium. It's not moving. And we know that it's being pulled down the plane by mg sine theta. And the force of friction acts up the plane, and it's mu times the normal force. And that is the frictional force, which must be exactly equal to mg sine theta. If it's not, the box will be moving. So we know that this is the correct answer when the box is not moving for what the force of friction is. And lastly, we would like to know what is the static coefficient of friction. Well, we know that the force of friction has to be greater than or equal to the pull down the plane in order for the box not to move. But nobody said that the box is on the verge of moving. Nobody said it's about to slip. So we don't have any way of telling where we are on the force of friction. So we don't have a way of finding mu. We can't tell. All we know is that mu mg cosine theta is greater than that. The mg's cancel, and we know that mu must be greater than or equal to the tangent of theta. But that's all we can say. We can't pin it down to a number that's exact. We can't say that mu equals the tangent of theta. We can only say that mu is bigger than that. We can box it in. We can say that mu static must be greater than 0, but less than, that mu sub s has to be at least tan theta. And that's it. Just bigger than tan theta, or equal to it if it's on the verge of slipping. Even if they told me theta, I still can't tell you what mu is. I can only say that it has to be bigger than the tangent of the angle. So it's not always possible to get an answer. So you will see problems that say can't tell. Don't be afraid to bubble those in, because sometimes they're right.